So this is a formula for a pendulum. The time it takes to do one swing is given by this formula. Let's establish the proportional relationship between the time it takes to do one swing and the length of the string. So for example, if I double the length of the string, what happens to the time it takes to do one swing? The period. What happens to the period? Will it get times by 2, or will it get times by 4, or will it get times by 8, and so on? Is the relationship, can we say that t is directly proportional to the length of the string, or can I say time is proportional to the square of the length of the string, and so on? We need to establish this relationship. So to do this, let's see what happens when we double the length of the string. So the time it takes to do one swing, if we double the length of the string, what happens to the time it takes to do one swing? We need to establish this. So set up two pendulums, one of length L and the other one of length 2L, because we're doubling the length. So the time it takes to do one swing is given by this. The time it takes to do one swing for this pendulum here will be given by, let's call it T2, will be given by 2 pi root the length of the string, this time is 2L, divided by G. So now I want to rewrite T2 as something in terms of the old time. So for example, hang on, I want to rearrange this to get into this form so that I can see that if you have like 4 here, you can see that it would be 4 times as long as the old time. Or if there's a 7 here, then I can say, oh, it's 7 times the old time. So I need to somehow rearrange it to get from here to here. So to do this, hang on. So to do this, we're going to use algebra. Hang on. We're going to use algebra. So using algebra, remember root a over b, that's the same as root a over root b. So I can square root the top and I can square root the bottom. So that would be 2 pi, square root the top, and then square root the bottom. And then basically I'm trying to extract this 2 here. Remember root ab, that's the same as root a times root b. So I'm going to break that up as one thing times another thing. So I can write as 2 pi and then root 2 root L, because I can use this on 2L, root G. So now you've got this block multiplying with the whole thing here. This gets multiplied to the top. So I can actually rewrite as this. I can drag the 2 out. So it will look like this. Hang on. Let me just clean this up. So now I can rewrite as this. So this is T2 equals, this gets multiplied to the top, but I'm going to rewrite it like this. 2 pi root L all over root G. Because all these 3 blocks are being multiplied together. I'm just putting the root 2 in front. So now I can drag the root 2 out of the fraction. So root 2 out of the fraction. I can drag the 2 pi out of the fraction. So it will look like this. It will make sense later on. I can visualize as one block times the 2 pi times root L over root G. But then root L over root G, that's the same as this. Root the whole thing. So now you can see this is the old time, and then it has grown by root 2 of an amount. So what that means is this. Hang on. What that means is the time it takes to do one swing and the length of the string. If I double the length of the string, this will get more increased by root 2. If I use the same process, if I increase the length by 3 times as much, if I times this by 3, use the same algebra manipulation, the root 3 will be here. So that means the time here will get increased by root 3. So you can see, times this by 2, it will increase by root 2. times this by 3, it will increase by root 3. So the relationship here is T is proportional to the square root of the length of the string. That's the relationship, okay?